Okay, let's take a look, see how these went for you. So for our first one here, 5 1/8 minus 3 5/6. First thing, of course, is to find common denominator, which is going to be 24. This is going to become 3 and 20. Now what? We're going to have to borrow. We cannot do 3 minus 20, so we have to borrow from the 5. This is a 4, and what do we do to this? Add 24. We add the denominator. So it's 27 24ths. Then, subtract. 27 minus 20 is 7 24ths. And 4 minus 3 is 1. 1 and 7 24ths. Our next one, 4 3/8 times 5 1/3. Do we need a common denominator? No, why not? Multiplying. Yeah, common denominator, the same name is only needed when we're adding or subtracting. So here we do not need a common denominator, but we are going to change them into improper fractions. So this is still going to be eighths. The name always stays the same. But what's it going to become? 35. Very good. Over here, it's going to be thirds. 16. 5 times 3 is 15, plus 1 is 16. And then, perfect. They can both be divided by 8. Yep. You're dividing by 4, which you can do, but then you'd have to divide by 2 again. Yep. So now we got 35 times 2 is 70, and 1 times 3 is 3. And then, of course, we would divide that out. 3 goes into 7 once, or twice, sorry. That's 6 with 1 left over. Bring down the 0. 3 goes into 10 3 times. That's 9 with 1 left over. So 23 1/3. Any questions on that one? Okay. Then our final problem. 8 1/2 divided by 2 5/6. Well, our division, the shortcut we use is to take the reciprocal and multiply. So it makes sense that we're going to do the same steps we did with multiplication. So we're going to change them into improper fractions. This is going to become 17 over 2. The denominator stays the same. This is going to become, well, 17 over 6, right? 2 times 6 is 12 plus 5 is 17. Bless you. Over 6. Now can I cross cancel here? No, well, there's nothing that would cross cancel anyway. But right now this is still division. Now the 17 over 2 doesn't change because it's not doing anything. It's the one that things are going to be done to. It comes first. It's the 17 over 6 that is doing the dividing. So we multiply by its reciprocal, which is 6 over 17. And now 17 and 17 will become 1 and 1, both divided by 17. And 2 and 6 can both be divided by 2 to give me 3 and 1. 1 times 3 is 3. 1 times 1 is 1. You get 3. You could have done 1 times 6 is 6, 2 times 1 is 2, and 6 over 2 divides out to 3. That works as well. Any questions on these? For this one? No, just 3. Just 3. Yep. Okay, well, today I want to take a look at some word problems that deal with fractions, and maybe even some complex fractions if we're feeling up to it. So let's take a look at, now I showed you the resizing deal. Resizing, we use it a lot in the medical fields, but we could also use it for recipes and whatever. If we have a recipe that serves 4 and we need to serve 10, well, we just use 10 over 4 and we multiply everything by that. You know, this is the old amount and the new amount. The new amount goes on top, the old amount on bottom. And we can use that to resize things. Sometimes called an enlargement factor. When we get into geometry, we're going to use that quite a bit as well. So let's say we have a recipe that does serve 4, and we need it to serve 10. And the recipe calls for 2 1/4 cups of a certain ingredient. How much of that ingredient are we going to use? Well, it'll be 2 1/4 times 10 over 4. Now you'll note 10 over 4 can be reduced. Well, you can take it down to 2.5, but we're going to put it as a mixed, or not mixed, we're going to put it as an improper fraction anyway to multiply. So we would just reduce by dividing by 2 and leave it as a mixed number. So we get 5 over 2. Now the 2 1/4 is going to become 9 over 4. So now we multiply through. 9 times 5 is 45. 4 times 2 is 8. We divide that out. 8 goes into 45 5 times would be 40 with 5 left over. So there's 5 5/8 cups that we would use to enlarge that recipe. Likewise, let's say that you're... I'm trying to figure out where I want to go. Let's just do a basic. Let's say you have a triangle, and the sides of this triangle are 6, 10, and 14. And you want to enlarge it. You want to enlarge it so that this side is now 9. What's this side here going to become? Well, that corresponds to the 14. And we're going to multiply it by an enlargement ratio. The 6 became what? 9. Which one's the new? Which one's the old? New is the 9, 6 is the old. Perfect. So it's just going to be 14 times 9 over 6. So, of course, we make that 14 over 1 times 9 over 6. I can reduce that by 3 to make it 3 over 2. 17 and 2 will cross cancel, give me 1 and 7. So 7 times 3 is 21. 1 times 1 is 1. So that's going to be 21. Make sense? Okay. Other places that this might come into effect. Let's say that you have a piece of wood that is 76 1/4 inches long. We need to cut into 8 equal pieces. Cutting it into 8 equal pieces means we are dividing by 8. So 76 1/4 divided by 8. What's that going to look like? Well, yeah, the 8 is going to be 8 over 1. Yep. And of course, we're going to multiply by 1 over 8 instead of dividing by 8 over 1. But, yeah, so unfortunately, we're going to have to do 4 times 76, which is 304. Plus 1 is 305 over 4. Now what? Yeah. We'd check to see if 305 and 8 would cross cancel. 8's only divisible by 2, 4, and 8. 305 is not. Well, 305 times 1. And 4 times 8. So now this is not an easy reduction back into a mixed number. 32 goes into 305. Let's try it 9 times. 9 times 2 is 18. 9 times 2 is 27, 28, which gives us 17 left over. So 9 and 17, 30 seconds. So each piece is going to be 9 and 17, 30 seconds. It does. Well, and also in the real world, when you cut, it's not just a fine cut. Taking the cut, take some out of it. So let's do this real world. There's 76 1/4, cutting it into 8 pieces. How many cuts does it take to cut something into 8 pieces?
7.
7, exactly. If you're cutting something in half and 2 pieces takes 1 cut, 3 pieces takes 2 cuts, it's going to take 7 cuts. Let's say your saw has what's called an 1/8 inch. You don't need to know this term, but it's called an 1/8 inch saw curve. What that means is the saw takes out an 1/8 of an inch as it cuts, which is pretty standard. So that means cutting this is going to take out how much? Well, 7 times 1/8, make this 7 over 1. 7 times 1 is 7, 1 times 8 is 8, so it is 7/8 of an inch. Which means well, 76 1/8, we're going to subtract 7/8 from it because the saw is going to take that much out of it when we cut. So I'm going to make this 76 2/8 to give me a common denominator, minus 7/8. And this is going to work just like any of our other subtract. Even though there's no whole number down here, we can still borrow. This will be a 5, and what's this become? 10. Yeah, but add the denominator, so 2 plus 8 is 10. So 10 minus 7 is 3/8, and that's 75. Now that is going to be cut into 8 pieces, divided by 8. So 8 over 1. This will be times 1 over 8. Now we got to do 75 times 8, which is... Oh, come on.
600.
Yeah, 600 plus 3, 603 over 8. And then 600 times, or 603 times 1 is 603. 8 times 8 is 64. And we have to simplify that back. 603 divided by 64. Let's try 9 again. 9 times 4 is 36, square the 3. 9 times 6 is 54, plus 3 is 57. And that is 27. So 9 and 27 64. Which is smaller than 9 and 17 32. So it is slightly smaller than it would have been. But not quite 1/8 of an inch smaller, because there's only 7 cuts for 8 pieces. I won't make you to subtract to see how much it takes out of each piece. That's not very nice. It ends up being 7/64 7/8 is what each takes out. The way you figure that, by the way, how much does it reduce each piece? Okay, we're going to throw little variables in here. There were no variables yesterday.
That's the exception.
Let n equal the number of pieces. So the amount that it reduces every piece is the saw curve. And this can be for anything. This can be for, cutting wood. It can be for, I don't know. Pretty much cutting anything where you're going to, the act of doing it removes material and cutting it out. Wood's the only one I can think of right now. Times n minus 1 over m. So in this case, the saw kerf was 1/8 of an inch. We were going to cut it into 8 pieces, so it was 8 on bottom and 8 minus 1 on top. So that's 1/8 times 7/8, which is 7/64. Not as tough as it looked. Okay, well, let's have a little more fun. If it doesn't scare you when I say stuff like that yet, you haven't paid enough attention. How would we do something like this? Yeah, this is just like any other order of operations. You do have to multiply first. So you have to do that first. So what are we going to do? 3/4 times, I'll put it over here so we've got room to do it, times 1/6. We can cross cancel to give us 1 and 2. 1 times 1 is 1. 4 times 2 is 8. So this becomes 1/8. So 5/8 plus 1/8 minus 1/2. Then what? You could find a common denominator for all of them. But at this point, there's something I can do that's a little simpler. 5/8 plus 1/8 is 6/8, which reduces to 3/4 minus 1/2. And then it's 3/4 and 1/2 both become 4ths. This is 3/4, this will be 2/4, give me 1/4. Many of you could probably look at 3/4 minus 1/2 and know that it's 1/4. Now, like you said, you could find a common denominator for all of them. Since these are both 8s, this would also be 8. It would become 4/8. So 5 plus 1 is 6, minus 4 is 2/8, which reduces to 1/4. So there are several ways you can get that. Once you're down to addition and subtraction, just addition and subtraction, you can find a complete common denominator for everything. Sometimes that's not so easy to do. Like this. Why don't you try that one? You know it's quick. See how you come out. Where would you start? In the parentheses. So 1 1/5 plus 1 1/6, which adds up to be what? 3 and 1/30. So everything else stays the same. What's next? Careful. Divide first. Yep. So that's going to be 5/4 times 30 over 91 divided by 91 over 30, but times 30 over 91. So 2 and 15 is going to give us 75 over 91. And then, now we can multiply, right? So this is going to be 5/4 times 2/3. It's going to be 5 over 6. That's as far as you got? You're right so far. Okay. Well, this is where it really gets hairy, because you got to find a common denominator for 91. 91 is not a pleasant common denominator. It's only divisible by things like 13 and 7. So 1 and 7/8, 75/91. You think about it for a little while, it's not too bad. Of 728 is your common denominator. So then, what is this? 637 and what? 535, I think. Does that sound right? You guys just gonna trust me?
Yeah, I'm trusting you. You're the math teacher.
Okay. And we are subtracting here. This is subtracting. So 637 minus 535 is 102 over 728. 1 minus 0 is 1. Are we done there? No, we can simplify this. That divides by 2, which will give us 51 over 364. So 1 and 51 through 64, so that's a lot simpler. Sorry. And then we got to add 5 6. So 1 and 51 over 364 plus 5 6. Oh, 5 6 has never been so difficult to add. Because we need a common denominator. Yeah, I know. The common denominator here, I will help you out, is going to be 1092. That's not so bad, right?
No.
Now, you do recall that yesterday I did tell you how to use your calculator if you have the fraction key. That makes these a little easier. So this is going to be, what, 151 over 1092? This is going to be, ouch, what is it going to be? 920, I think. 1092 divided by 6 is 182 times 5. It's 910, not 920. Okay. I knew something fell off. And we're adding. So 910, 151 plus 910 is 1061 over 1092. 1 plus nothing is 1. Anybody get that? Not even close. Sorry. Most of the jobs I've ever worked in, I've worked some pretty precision manufacturing jobs as an engineer. Most of the jobs I've worked, you could probably get away with calling that 2.
I got the bottom number correct.
1092?
Yeah.
Yeah, that's a start. Oh, wait a second. I'm off here anyway. This should be 153. So this should be 1063. Is that better? Is that what you had? No? Okay. But anyway, if you look at this, 1 plus 1063 divided by 1092, you're going to get 1.973. That's really close to 2. Technically, that is 27 and 26 thousandths off of 2. I worked in injection molding and extrusion dies, yet 26 thousandths probably does make a difference, but it's, yeah. Okay, so anyway, we've had our fun there. Let's take a look at this a little bit differently. If you guys haven't figured out by now, I'm a math teacher, which means I'm not really a nice person. Yeah, it does, yeah. So let's say we have 3/4 plus 1 and 5 6 over 8.5 divided by 1 and 1/5. What are we going to do here? Well, bottom or top, it doesn't matter. This is a enclosing symbol. You have to do everything on top separate, everything on bottom separate, then divide. So it really doesn't matter which one we do first. Let's do the top. Why not? We got 2 3/4, 1 5/6. We're adding. We need common denominator, which, oops, that should be, why is it 1 1/5? Holy cow. 1 5/6. Okay. Common denominator will be 12. Good. This is going to be 9 and 10. So 9 plus 10 is 19/12, which is going to be 1 and 7/12. So we keep the 7/12, carry the 1. Everybody see where the 7/12 came from? All right. So we carry the 1, we get 4 and 7/12. So on top of this is 4 and 7/12. Now what? Bottom. So this is going to be how many halves? Yep, 8 times 2 is 16, plus 1 is 17/2. This is going to be 6/5. It's tempting to cross cancel, but we can't. We got to do the reciprocal first. So 17/2 times 5/6. And now, unfortunately, we cannot cross cancel. So 85/12. Now, I could reduce this to 7 and 1/12, but I'm not going to. Can anybody see why? Well, what does this fraction bar mean? What operation does that indicate we're going to have to do? We're going to have to divide. And when I divide, I need improper fractions anyway. So why reduce it just to change it back? So we have 4 and 7/12 divided by 85/12. 4 and 7/12 is going to become 4 times 12 is 48 plus 7 is 55. Very good. Times 12/85. This problem is going to work out way nicer than you thought it was going to. The 12 and the 12 cancel out to make 1 and 1. 55 and 85 can both be divided by 5 to make 11 and 17. This is 11/17. Not so bad? I think you guys want to try one.
Might as well.
Why not? You're here.
Are we going to have 1,090 seconds for a denominator?
I'm sensing a little bitterness there.
Not at all. Not at all. Stating fact.
Just a touch of hostility, maybe. I'm feeling a bit hurt.
Jab is back, though. Jab is back.
Not really. Don't worry. There, give that one a shot. Let's see how you do. Let's see how you did. So we're going to start out on top here. 2 1/3 plus 1 5/6 times 1 3/5. So we're going to be multiplying first. This is going to become 11/6, and this is going to become 8/5. Cross cancel, give me 3 and 4. We now have 44/5. Or 44/15, I should say, or 2 14/15. So 2 1/3 plus 2 14/15 is what we're at. Well, fortunately for us, we have a common denominator here, which would just be 15. So our 14/15 stays the same. This is going to become 5/15. 5 plus 14 is 19/15. Keeping the 4/15 and carrying the 1, we're at 5 and 4/15. How many of you had that for the top number?
5 and 4/15.
5 and 4/15. On bottom, first thing we're going to do is do the division. This is going to be 27/4 divided by 9 halves, so times 2 over 9. Cross canceling 4 and 2 is 1 and 2. 9 and 27 is 3 and 1, which gives us 3 over 2, or 1 and 1/2 minus 3/4. If you left that as 3 over 2 because you knew you're going to need to borrow, that's fine as well. So 1 and 1/2 minus 3/4. Common denominator here is going to be 4. So this is 1 and 2/4 minus 3/4. Borrowing from the 1 makes that 0. Makes this 6/4. Minus 3/4 is 3/4. 6 minus 3 is 3/4. So 5 and 4/15 divided by 3/4. 5 times 15 is 75 plus 4 is 79. 15th times 4 over 3. Cross canceling is no.
I got 316.
316 over 45 is correct for that. So now, what is it, 6 or 7? I think we're going to try 7. 7 times 5 is 35, carry the 3. 7 times 4 is 28, 31. There's 1 left over, 7 and 1/45. How many had that? A few of you? Cool. Is there anybody that feels that they have no hope of ever being able to get that answer? Okay. All right, it happens sometimes. Okay. Well, I think that is enough suffering for the day. There is obviously you have a quiz that's due by 11:59 p.m. tonight. That's the one from yesterday. And there's a homework.
Those are mine mostly.
Okay. Homework due for Monday. And of course, remember, 1 week from today, next Thursday, is Unit 2 test. So Monday will be our last lecture before the Unit 2 test.